Now, this should be reviewed by DOGE and Trump and so forth. They went up there to this asteroid, and they grabbed a chunk of it and brought it back. Cost us well over $1 billion. Now, this is National Science Foundation. We fund that. Smithsonian, I don't know. I think we do that too. Whatever, it doesn't matter. What we need to do is examine what has come back. And I have gone back and forth with NASA about this on a live thing, and I kept commenting, that is a heart, that is heart muscle, and they finally blocked me, which I'm blocked from everywhere, and Fermilab too. That's the next one I'm going to go into next. But let's just see why I make my claim that this is a heart. All right, chemistry plays a huge thing in this. Do cell membranes contain phosphates? Yes, cell membranes, specifically the phospholipid bilayer, contain phosphate groups. Every single thing in your body, even red blood cells, have these phosphate groups surrounding them as membranes. Here it is right here, phosphorus, phosphates. During certain events, it can boil down to become aluminum silicates. It loses some of its nucleus, basically. It's called nucleosynthesis, and it goes down to become, the daughter decay elements become silicon and aluminum. You have to understand a lot about this, and I do. This is what is in Bennu samples they brought back. So these are the samples they brought back. And these little white spots here are phosphates. This is the big picture. This is a little different without the real glowy stuff. This is under a certain light that makes the phosphates glow. And this is not under that same light, but you can see there's layers of phosphates, and there's sarcomeres in between those layers. These are sarcomeres. That's the layer, then the sarcomere layer, then the next layer, then the sarcomere layer. These are bilipid phosphates. These are phosphates. They said the phosphate surprise. We never expected this. They didn't expect this either, which is the blocky little muscles. These are muscle fibers called sarcomeres. And that is what's in all muscles, and they pull together. And because there's a whole batch of them, they can do a lot of flexing. In the heart, they literally twist and pump your heart. Now, that is a heart. And this is a chunk of muscle from that heart. So why would I say it's a heart? Because this is a heart too. Of course, this is a terrestrial heart from a heart attack victim where the muscle ripped. These are the phosphate layers. Same as you saw in the one from Bennu. These are the sarcomeres, the little blocks. There's layer after layer after layer. They came back grabbed a chunk, brought it back, put it on the table, and cannot see what they see. This is it right here. These are the phosphate layers. They know they're phosphates. Phosphates are in the membranes. Every single membrane in your body has phosphate layer, phospholipid membrane. It's just the way it works. And here they are right here. And these are the sarcomeres that make the muscles pull. This is not a mystery. All the DNA, the uracil is in here. That's a killer. I mean, if you understand chemistry, you got to understand chemistry, biology, how it works, how nucleosynthesis, nucleophilic reactions work, which is the transferring of molecules in and out. As our body uses different things, it has to break them down and build them back up again. It's called enzymes, breaking them down, and proteins, building them back up. The enzymes create the products, the proteins build them back up. It's a simple process, but you need the enzymes. The enzymes are created from bacteria. So I would like to know if is there any biology still in here? Is there any bacteria still living in here? Because there very well could be. They have to look and see, because the biology is literally, there's living organisms in us right now that you have to have. They're called bacteria. Bacteria. If you didn't have the bacteria, you won't have enzymes. If you don't have enzymes, you can't break down the products. You would die within less than 2 minutes. Okay, my friends, I'm just going to explain to you what the Rogerian argument is. And it was named after a guy named Carl Rogers. And here's what it's all based around. The Rogerian argument is a form of argumentative reasoning. In other words, you're not going to be, you're going to have opposing positions. So it's argumentative, all right? But you got to be polite. It's reasoning that aims to establish a middle ground between the parties with opposing viewpoints or goals. I want this, you want that. I say this, you say that. Can we meet in the middle? What do I have to present as evidence, and what do you have to present? What is the middle ground? That's what a Rogerian argument is. However, here's the deal. You have to discuss it. It was developed by Carl Rogers, adapted to rhetoric by writing scholars Young, Becker, and Pike. The speaker seeks compromise. So I am the speaker. I seek compromise. I acknowledge the positive aspect of each party's argument to arrive at a mutually beneficial solution to an issue. What does that require? That requires me speaking and making a statement and a claim, and them making a counterclaim, and then me addressing that counterclaim, and then them addressing my counter, and back and forth until we sort of settle in on, you have a valid point here, I have a valid point here, back and forth. Maybe I have no valid points. Maybe they have no valid points. But that's what a Rogerian argument, it takes two to Rogerianize. So, as they will not speak, I will speak as I was them. And this guy is David Klinghoffer from Intelligent Design, Evolution News. You know, everything came from slime is what they claim. That's what they claim. I say that's not true, so that's my side of it. Now, his to say could be the most ridiculous idea about how life originated. Well, no, I have a much more ridiculous one. This is where they went out and landed on there, picked up a chunk of this and brought it back to Earth. And guess what it had in it? It had everything that is found in life. They found 16,000 kinds of organic molecules. The most remarkable, 16 amino acids. Those are very complicated little proteins. Then they found the DNA, you know, it seems like our DNA stuff is built from these 4 units called nucleobases, you know, CTAGs, and the Bennu rocks contained all of them. They had all the DNA bases to make a proteins. Our cells copy a gene from the DNA to a similar molecule called RNA. They had all that stuff. We used 3 DNAs of the nucleobases plus one of its own called uracil. That's the key right there. This just doesn't just float around nowhere. This is from biology. Bennu contains the uracil too. Isn't that practically like, oh no, that's just silly, that's just nothing. No, it's not. It is, and not only that, that, my friends, is a heart. I mean, there's so much wrong. It's incredible. And it's because they can't open their eyes. They can't speak up. They're afraid to speak up. They'll lose their jobs. Everybody's scared to death of academia. Academia can destroy your life just like that. They can put you out of business. They can destroy you. And they do. And they just, you failed, you failed, you failed. You didn't say what I told you to say, you failed. Now, this is a heart. It's in space. This one right here is psyche. It's another heart in space. These are the valves. And the top pops right off because there's a black and a red stripe. It goes all the way around. And those oppose each other. It's called iron banding, and they just pop right off. You talk to an autopsy guy, they say the same thing. As a matter of fact, when I told the autopsy guy I work with about this, he says, you know, I always wondered why that happened. It just pops right apart. It's called iron banding. And this has tubes coming out of it, in addition to the valves. There's tubes running out of these hearts. You see this? It's just amazing they don't know what they're looking at. That's Bennu. That's a little scruffier than psyche. But this is, they have little tubes coming out here and there, and you got all that plumbing. The plumbing breaks right off there. And then you got some tubes here and there sticking out, and that's exactly what you got here on psyche. That's a tube. That's not a crater. That's a tube, not a crater. These are the colors of blood, the red, the black, and the yellow. That's the iron oxide states of blood. These are valves. This is a heart. And that psyche, that sucker is enormous. And they look at it and they know it's made out of all metals, because almost all blood is metal. Blood is just fluid with literally metals in it, called transition metals, and they float around these things right here. And they have charges on them. And the charges pick up ligands. Ligands are little molecules that attach to all these charges surrounding the transition metals. And they go through your body, and they give up and take, and give up and take, and give up and take. And that's how you supply your body with the products that the enzymes break down from the things you eat. You don't eat a carrot and all of a sudden it turns into a muscle. Obviously. You got carrot goes in you got a whole bunch of different products in there. An enzyme comes up, goes, next thing you know, you got all kind of floating little pieces coming up out of it. It broke it down. Enzymes are destroyers, and they work sometimes up to billions of times in 1 second, which would take a year to do that same chemistry if you didn't have the enzyme. So they are pretty important, and they are only created from bacteria. So you got tons of bacteria, thousands and thousands of different species living in each one of us. The ones that don't have the right species to break down the right products, they're going to get sick. Bacteria, that's another thing. I want to talk to Kennedy about the bacteria, about fecal matter transplants. They need to look into that, because when you get a good, healthy person, their poop is going to be good and healthy. Even Yale says, eat, poop, and live. They know about this stuff, but they can't talk about it because it makes them seem like they're foolish. Like giants. The giants, there's absolutely 100% certainty, because I have them, they're DNA tested. Nobody will examine them because they don't want to look like they're stupid. They're being stupid for not looking at it. This is a heart. That's a heart laying here somewhere. And I'm not sure where it is, but it's a heart. And I got so much stuff of this. This is a hair follicle. That's a hair follicle 2 inches wide. This is how I got into this study in the mud fossils, and I realized academia is just a scam. They have you intimidated if you don't say what they tell you to say. They keep your money and fail you and destroy your life. Literally destroy your life. This is what Trump's got to look into. Get this straightened out. Yale has $40 billion. What they did to me was a disgrace to humanity. They would not allow to look at my specimens, and then wrote a paper saying that this stuff does happen, but only slimy evolutionary creatures. And then they said maybe this wipeout of all these creatures, which is my mud fossils, even Caesar here was part of the destruction here. There's just feathers on his back of his head. He was a goose. He was living. Now, at the same time as these things died, and they all have one flat side because they died and they just laid in the mud like that. And then all the transition happened because of the heavy silicates and salts. I have all this stuff done. I have all the chemistry done. I have everything done. And I've had mud fossils tested, 3 different DNA tests. I've had 7 CAT scans, and they refuse to examine this stuff. Now, this is where Trump's got to jump in. I want to see DOGE do something. I've been sending things to him. I told everybody, please contact. I tried to contact my senator, Senator Chris Murphy. Nothing. He's a Democrat. I don't care who they are. Democrat, Republican, Independent, A, B, C, D, E, F, G. Who cares? I want some truth. And here you go, truth social, truth this, truth that. I see none anywhere. 0 across the board. Whatever position they want to take, they take, and that's the end of it. Go home. Get away, stay away from us. That's what happened to Fermilab. When I found the same particles they found, right here, these are the Fermilab particles. This is the picture from Fermilab. I sent them ours. I said, we found your particles, but we didn't use protons, we used light. So we didn't have to dig through all the trash you guys dig through. And I was really nice in the beginning. I tried to be very nice and polite, and boy, I'll tell you, they just treated me. The guy from Fermilab, Don Lincoln is his name, told me I was a tinfoil hat guy, a disgrace to science, and he would never look at a thing I had to send him. And he is the top researcher, or supposedly senior researcher at Fermilab. That place should be shut down. These are the particles, spending billions and billions of our dollars. The only one that would engage with me was University of Geneva, when I went there to take particle physics. I didn't actually physically go there. I took it through Coursera online. But they engaged with me back and forth. And then when I showed them this stuff, we had a discussion that no, this was not possible because CMOS is destroyed by these high energy particles. And I said, no, that is not correct. Your high energy particles are chunks like that. My high energy particles are light. They're chunks like this. That is what CMOS is made to detect, is the particles. And there's no interference, because you sit back here and it just bangs into it. Otherwise, it would just go somewhere else. So you're not putting anything in there to sense anything, and you're not adding any energy in there. That's called the observer effect. When they have to put a device in there to extract energy to see how much energy is there, they just changed it. If they flood light in there to illuminate it, they just changed it. We sit back here and wait for the light to bang into us. We change nothing. And that's what you get using CMOS. And this, my friends, is fission and fusion. This together is the strong nuclear force. And these are subatomic, which means nuclear particles. These are the particles that make up the nucleus. And 1,839 black and whites make up a proton. One of these is an electron. Two of them back to back is a photon. Those are and then you start to get into protons, which apparently, for some reason, there's certain quantities that become stable, and they call the periodic table, the periods. Boom, boom, boom. And this is 1,840 or so. Helium is not 4. It's 2 protons and 2 neutrons. This helium is 7,300 and something, all right, of these particles. All right, they think a proton is this. And you can smash it into quarks and hadrons and this and that, and they get all the way down to Dirac neutrinos, which is the neutrino we started with. These are the neutrinos. The black and the white is a neutrino. That's what we started with. This is again from the same guy, Don Lincoln. These are the particles. It's totally backwards. This is not matter. That's energy. This is the matter. We are made of dark matter. That has no mass to it. This is what you fill your car up with the white part of the dipole. The Majorna is in between, where it's not quite a photon particle yet. And I can show you those too. Here it is right here. That's the photon. These particles up here are the neutrinos. They're not quite powerful enough yet to become a photon. Photons are only seen when they bash into something and they bounce back, or they're seen as they bounce into their own self, because this is hitting the Venturi, pushing itself back. So this particle sees this as a wall, and it pops up as a photon. Otherwise, it would be the Majorna. Well, I mean, this is the Dirac neutrinos, but they're back to back, which makes a photon. They see them. They just don't know what they see. All right, and this is the in-between. So this is like, sometimes they're this way, sometimes they're that way. That's what I see. And then this is the photon, but it's only half of a photon, and it's this way, polar up and down to the Earth, not flat like this. And it's upspin and downspin, and I can show you that too. I show you everything that I'm talking about, and I want to speak to somebody at DOGE or whoever. This is upspin, because the white is facing up, and they always polarize towards the Earth. This one's the downspin because the white is at the down. They're spinning like this. As the one in the front charges up, it flips to the back, and the other one comes front. I just showed you that. Right, well, look at the green. I can show it in the green right here. This time the particle's not coming straight across, or straight across this way. However, this is always straight up and down to the Earth. You see it? Now what's going on here? How come it's fuzzy looking? Why do you think that's going on? I can tell you why. Because this is the downspin, and it's going this way, smashing into all these particles that are in front of it. So this one starts to glow. And once it achieves a certain mass of glow, well, it's just not taking in mass. That's the key. It's like field to field. And you take a magnet. All right, you just take a regular magnet. Hold on, give me a second. All right, here we go. You take a regular magnet. And I'm telling you right now that there's a field there. Oh, there's a pushback field. and then you go to the side, it sticks. But at a certain place in that field, there's push. And I could feel it. It almost feels like I'm hitting a wall to go through that field. So there's a field around here that's got to push through everything that's in front of it. And that's glowing, and it's going to flip to the back. That is the way they work. And this has the same neutrinos down here. But don't forget, it's going sideways this way, but still straight up and down. That's the key, upspin and downspin. They see all these things in this. These are what they do. They take big ones like this. Neutrons, protons. Proton is an uneven number. It's about 1839. Neutrons have an even number. They don't want another one, and they don't want to give one up. This one wants to either attach with somebody else or take on another particle to become whole. They're only one tiny little particle apart. They're only just one of these tiny little particles apart. That's why this one wants to add or give up. This one just says, I'm good. But when they bang them together, they just get all this debris. Now they see exactly the same particles I showed you, these here. Those are photons. But they see them big like that, and they think it's a particle. They see these, and they think that's a separate particle. That's a separate particle. This is a separate particle. This one here, smaller than that, is still the same particle, but they think it's different. This one over here is in the middle somewhere. They think that's different. X particles are just huge chunks like this. This is what Fermilab, well, I talked to Fermilab. He just blew me away. But when I went to Geneva, to the University of Geneva, I know they consulted with Fermilab, with CERN. Because we went back and forth, and I said, no, I can see these particles. You can't see them because you're using this. And when you get hit with an X particle, it destroys the CMOS. Well, they ended up upgrading CERN to use CMOS and putting in radiation-hardened CMOS detectors, because that's the only way you can get a reading of what you're looking at without interfering. They were interfering, and even Don Lincoln, the guy that I had so much trouble with, wrote in his paper that anytime you looked at it, it changed it. Well, of course it changed it because they're flooding light into it. He said the field would get bigger. Well, yes, because you just threw more field in there, more light. You said just more bigger particles. It just expands the field. I tried to explain this to him, and boy, I'll tell you, that right there is unbelievable. The amount of money they have spent, wasted, and the opportunities to use this as free energy. I think we can get free energy, because right here we have separated the black away from the white. All you want is that white, and if you could harvest it right there, you put a receiver right here that harvests all that white, which has no mass, literally no mass. It's just the field. And the black stays away because you can't get through the Venturi. You harvest it there and you put that in a battery. The battery will not increase weight because it has no mass whatsoever. There's nothing there. It's like the field that I just showed you. Somewhere in there, that field, there's some kind of energy. Like I said, I feel like I'm banging into a wall when I hit right there. Boom, click, 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 click. So we know there's some kind of a field going on there, but I don't see any matter there. There's no matters outside of this part. It's time to talk to me. That's my statement. I could try to contact DOGE. I try to contact my senator. I try to contact literally everybody. I'm on LinkedIn. I've tried a bunch of those people. Not a single response from anybody. Nothing. You want to talk about Higgs fields? They're talking about being this big upgrade they did. They're going to see millions of Higgs fields. We could have billions, trillions of them within a few minutes. These are Higgs fields. And that's that white particle coming through there. Now, again, we got problems with CERN, yes. Fermilab, Yale, they would not allow my research to be seen, basically. You know, I can't say they did anything to stop my research from being seen, but they would not see it, which is their fiduciary obligation to their students was absolutely breached, and their obligation to society as one of the leading places that say, you say what we tell you to say and you're going to be smart. No. You say what they tell you to say, or they will tell you that they're going to destroy your life. And they will. If you get failed for not saying what you did. And that's what they did to me, not at Yale. It was another one. But it just didn't matter. When I saw that, I knew. Because nobody would stand up for even talking about the truth. They won't, and they still won't talk about it. Nobody's talking about this. Years. I've been 10 years now showing this. Started out with CERN and Fermilab and every one of them, Lawrence Livermore, every single one of them I sent it to. NASA, absolute zero responses. And this, the same thing. Billions and billions. And now I saw Don Nelson, I think his name is, well, Nelson something. They want to go out and pick up samples from Mars. Mars is nothing more than this too. Mars is nothing more than it is here on Earth. And I can show that, and I have. These are sarcomeres, and there's just giants on there, just like there was here, just like this. Big hearts, big bodies, big muscles, big battles into space. They said there was giants in space fighting, battling, battles in the heavens. I don't know, that just looks like it to me. Something happened there to send out these hearts, these are big. So that's why they won't talk, because they're just afraid they'll look like fools. Oh, this has got to be silly. No, it's not silly. It's way beyond what they are capable of doing. The incompetence level is not even possible for the average person to believe. I can't believe it. I'm showing this. No, don't show us that stuff. And this is with a cell phone. You can do this stuff for almost nothing. Here's the cell phone we used. And there's the laser. To do these research experiments that they have spent, I'm sure, trillions to do. And not only that, we separated the black from the white. Exactly what they say. Muon gives a well-defined black cone. Electron showers gives a shower of white particles. Yes. And when you can do this, you should be able to get at least 200 times more energy than you started with. So I'm sorry, that's just a fact. That's what they claim. And I'll show you what CERN shows. And it's time this gets seen. This is just ridiculous at this point. See, this is the physics of it. Protons they're doing. They do huge machines, hadrons, all kinds of collision beams, decay of the hadrons, flux energies, and neutrinos. And then they created this subset and so forth of electrons and muons, which is what we started with. And that gave them the neutrino interacting up to 100 billion volts, electron volts, up to a few trillion electron volts. It's incredible the increase in energy when you can pull that white away from the black, which we did with no added energy. All right, they should not miss this. DOGE, Trump, Musk, all of them. This is the energy you start with when you create electron showers. You come in with almost no energy at all. And as they start to stack up, the energy starts to increase. And once it hits that Venturi, right up through, this little U means potential energy. What can you do with that? You do whatever you want with it. But that's potential energy. It's energy. And here's what it was originally down here. And just by going through the Venturi, you bring it up to here. And this is what happens. You create additional electrons as a shower. These are the number of electrons in the shower. Maximum number of electrons, the E. It comes in and starts to build up as they start stacking up against themselves. It's more and more and more and more. And all of a sudden, they get sucked through the Venturi. And at that point, that's when you get the showers. This is a shower. 400 started down here with like almost nothing. So you get the way I'm taking it, you got about 200 times, I would say at least, more energy than you started with. And we did absolutely nothing to increase that energy value. Nothing. It came through here. And it came out the other side with the electron shower here. That's it. We just made a Venturi. Very simple, very easy, and nobody will look at it. I've sent it to DOGE. I've sent it to everybody. I've sent to all of the different colliders and laboratories and everywhere. Zero. The only one that would even discuss it with me was the University of Geneva. And I believe I presented facts that they couldn't get away from, and they didn't. At the end of it, they just said, well, that's interesting. We'll follow you on Facebook. I said, I want to interact with you people. I want to do something with you. No, we don't do that. We'll watch you on Facebook. I'm serious. That was the last communication I had with them. And I said, look what I'm doing. I'm showing you light waves accelerating. I'm showing Higgs fields coming out of my ears. I'm showing electron showers. This goes back to, I went there in 2015, I believe is when I went to University of Geneva. That's 10 years ago. And it's just been, I put this out almost daily, and there's just nothing. Same thing with this. This has almost been, when I knew they were going up to get that sample, I looked and I knew this was a heart. And I said, when you come back with this, here's exactly what you're going to have. This was before they even came back. And it was all the blood metals that are in here. And I know exactly what's in there. And I put it, and I have the video, it's still up on them. And not a single word from them. And everything I said was correct. Not only that, I had no clue they would get deep enough to grab actual muscle. But when they hit, they must have thought they were just going to grab a hard rock, because that's what they're talking about, boulders. All that is laying around the surface is a bunch of extra blood. That's what the boulders are. They went through that blood because it's just all fluffy, basically. It's just all little bits and pieces. And they went down inside, and then they hit the actual muscle, which is much more, stronger. And when they hit that, because they went down into here, through this is just nothing more than little blood blobs. It's biological body, whatever. It might be the membrane around the heart. It could very well be that. But anyway, it's they went down deep inside, came back with the actual muscle. It's exactly identical to this heart muscle. Now, why can't we even get a discussion? I can't get a discussion. If there was a discussion, we could get somewhere. Boulders and beyond. We're going to try. How can we better understand? Well, talk to me. How about that? Maybe you can better understand if you pay attention to the actual. I mean, it's just what it is. And I'm sorry to keep rambling on about this, but this has got to stop. We got to get some reality in our lives, and we have no reality right now. None, zero. As far as I'm concerned, they tell you what you're going to say, and you better damn well say it, or they will destroy your life.